Guys,
Greetings.
greetings, Earthlings. Lynn, did you want to share from your end, or did you want me to do it? You're on mute, sir.
Yeah, I keep doing that.
Okay.
Yeah, I can share from this end, and if it doesn't work out, then we'll switch back to you.
Okay, I'll have it open and just ready to go, just in case.
This is my first time actually playing with a multi-screen PowerPoint and
It's
laser
kind
cutters and
of
stuff like
nice
that.
the way that Zoom does it, because it'll actually let you have your speaker notes open on a different screen. So
Yeah, my problem is I think it's going to cover up my video view with the speaker notes. So I'll rely on you if anyone's waving their hand to cut me off in the audio side.
yeah, and we'll use the raise your hands thing too if people have questions, but I'll kind of guide everybody through.
Yeah, hopefully I haven't figured out a way that I can actually present it, see my viewer notes, and still see the Zoom meeting all at the same time.
Did you want to try sharing real quick so you can get an idea of what it looks like?
What were you going to say, John?
Need triple monitors.
Yeah, I know. I only have two.
Yeah.
You can go ahead and try sharing right now if you want to.
Yeah, let me try that.
I will.
Everybody else is seeing.
Well, that's an interesting concept. Let me just try that. I've got my monitor over here to the side. That is not the URL that I'm after. But y'all are seeing my screen?
Yep. Yeah.
Okay, good.
I'll be right back, guys. Having a keyboard problem here, but I'll be right back.
That's the thing. If you sign in on a second computer, you see exactly what we see.
Yeah.
John, can you confirm that you have a co-host?
Who did you ask, Jeff?
You.
Oh. I have the ability to share screens.
I made you co-host. It should in the participants list. You should see that.
Okay, let's see.
Let me see here. I'm gonna bounce out of the meeting. Hopefully, it won't kill everybody's connections here.
Yeah, I'm a co-host. I see that. Thank you.
Okay. Yep, I can just leave the meeting and leave it running. All right, I'll be right back.
Okay. Okay, that was weird. So y'all are still seeing my screen, my shared screen, right?
Yep.
Okay,
Yep.
then I messed up on, switch to shared content. Okay, yeah, I messed up the second monitor. It was seeing me instead of what y'all are seeing. Okay, got it. So when you see me look to the right, I'm looking to see what y'all are seeing.
Except the screen is mirrored, so it looks like you're looking, well, yeah, to your right, to our left.
Right. Okay. Oh, this is going to drive me crazy. Because yes, it's a separate PC, but have you heard of Microsoft's Mouse Without Borders?
Yes.
I have Mouse Without Borders. So the PC that I put the extra view on is actually off to the right of my normal laptop screen. And when the mouse moves over there, it's over there. And to the left of my laptop screen, I have another laptop with Mouse Without Borders. So there's 3 monitors actually horizontally and 1 vertically, just to drive me totally crazy. Okay, get rid of my reminders. How's everyone enjoying the new year so far?
So far, so good. It's freezing cold out here. You're in the right place, Lynn.
Yeah, I was talking to some folks in a shared development project. They're over in the Netherlands, I believe. Brussels, whatever country Brussels is in. And they were commenting that it's 0 Celsius over there. And they asked, they brought it up, so I'm not guilty of pushing it on them. And I told them, yeah, we had a cold front. It's 65 Fahrenheit here.
Yeah, well, right now the outside temperature is -4 and it reports a feel like -22.
Man, that's cold.
It's cold.
Florida blood slows down when we go below 50.
The joy, Lynn, I forget what part of Florida you're in.
We are on, I'm in the central East Coast, about 40 miles south of Cape Canaveral.
Okay.
So literally I step out in my yard to watch the rockets go up.
I was going to say, yeah, you probably have pretty good view. You know, I was surprised. I lived down in South Florida for a few years in Fort Lauderdale. And I remember when I first moved down there, I was in Plantation, and they're getting ready to start the countdown. So I said to my girlfriend, I'm going to go outside and see if I can see anything. I know we're like almost 400 miles away, but I'm going to see. And sure enough, didn't see a bright orange arc across the sky and a little white thing at the beginning of it. And I saw a few launches like that.
Yeah, it's definitely impressive. I had a ham friend over in the south coast of England who, when the shuttle was launching, he would go out and watch the separation of the external fuel tank from the shuttle with the telescope.
Wow.
That was phenomenal that he could actually A, find it, and B, keep it in frame to see it.
That's amazing. You know, I'm going to pause this just for a second so this isn't caught on. Let's maybe give it like another minute or two just to see if anyone else graces us with their presence, and then we'll go.
That's fine. Jeff, you were going to say something, I think?
It was just
Martin.
about what I was just talking about.
No, Jeff Martin was going to say something.
Nope, just agreeing.
About,
People watching if they need to see the information.
oh, okay. In
And
front
that
of a
REM
live studio audience.
Yeah, that REMDev that you should see showing up there is my other PC that's watching what you're seeing.
We're going to enter the fourth dimension. All right, well, here we go. Ron joined. Now the party can start. Oh, he's not on audio yet. There he is. Ron, I was just saying now that you're here, we can start the party. All right, Lynn, go ahead and get started. Well, or I can kick it off. So guys, thanks for joining tonight. You know, I'd asked Lynn to do this presentation back, gosh, I think when we first started discussing the knowledge share sessions that, you know, it seems like July is far, far away, but if you think about it, I mean, it's already been 6 months since Golden Packet 21. So time is flying by. July will be here before we know it. And I mean, this past year's event, we had some successes, we had some failures. And I think there's a great deal that can be learned from the failures. I mean, that's, you know, that's why we learn about history, so as to not repeat itself. And, you know, I think just amongst the group that has been pretty heavily involved in this, both before and after this year's event, that we all agree that education is the #1 way of getting people to be more self-sufficient. And being able to troubleshoot in the field is of paramount, especially with an activity like this or an event like this. And you know, myself having experience with APRS, I know that there's people who are new to it. There are people who have many years of experience, and then everything in between. And I mean, frankly, I can configure my radio the way somebody tells me to, and validate that it works the way it's supposed to. But that doesn't mean I understand why things are set up the way that they are. And the engineer in me very much wants to know why. And I think it's a great benefit to everybody to learn as much about, you know, why we use the things that we do. So, you know, I'd ask Lynn if he would be willing to go over it. And he said, yep, absolutely. So that's what brings us to where we are now. I've seen the slides. You guys are in for a treat. The slide deck is incredible. So Lynn, with that, I'll turn it over to you. I'll shut up.
Okay, thank you, Jeff. And it is my pleasure to be here this evening. Jeff threw the title out, "What does this button do?" And I kind of liked it. But just to give it a little subtitle, I threw in, or why Appalachian Trail Golden Packet uses the APRS settings that we use. Because it's real easy to follow a cookbook, plug the settings into the radio and hope it works. But if you understand the intent behind those settings, it's a whole lot easier to extrapolate when this is not working, what setting do I go look at to see if to fix it? So that's the general idea behind tonight's presentation. And if I can focus in the right place, the overall, what we're going to talk about tonight is we're going to start with some basics. Some of you may know this, and I'll be preaching to the choir. Some of you may have seen it, but not really understand the pieces parts. And some of you, this is going to be new stuff. So if I'm going over your head, slow me down. If I'm dragging on too long, tell me to speed up. But we're going to start with the anatomy of an APRS packet. Those things that we see when you look at the raw packets at aprs.fi, we're going to talk about what the different pieces parts there are. Specifically, then we're going to focus in on the path selection, because the path is what makes the Appalachian Trail Golden Packet event actually work. And the way the path works is it actually triggers the Digipeaters. So we're going to cover Digipeating 101 plus. So we're going to start at like basic Digipeating and then go very quickly into all the various features and functions of Digipeating. And then we're going to dive into the AT Golden Packet radio settings, and specifically why, the intent behind all those settings that you see and how to set up your D710. We're going to talk about some things you might try before you actually go out to the trail. If you're blessed enough to have 2 APRS radios, you can actually test most of the features that your station is going to need to use on the trail. And then if we have time, because I tend to talk a lot and I have about 40 slides, which means I don't even have about a minute apiece, we'll dive into a little bit of Golden Packet station problem diagnosis. When this isn't working, here's what you should look into. But before we get into all that, who is KJ4ERJ and what is APRS? I am Lynn Deffenbaugh. You can find that up, looking it up at QRZ. But my interest in amateur radio actually started back in the 1970s. I read an article, I have a very vivid memory of this, probably it was in Popular Electronics, and I remember it talking about a used bit and these path identifiers, and it had to be an article about AX25. But I didn't have money, I didn't have any mentors, so I just let it go by the wayside. Fast forward to 2008, my son, KJ4DXK, and 2 of his friends decided they were going to get their licenses. And then they told me that you don't have to know code to get your license. So I said, count me in. Studied up, got my technician, got my general, and then got my extra, specifically because of APRS. We were going to do a trip over to Spain, and for the CEPT to work right, for me to transmit APRS in Spain, I had to be an extra in the United States. So most people get their extras to go do HF. I got my extra to do APRS on 2 meters yet to boot. I've always loved GPS stuff. My son did GPSs. We played with geocaching. He built me a GPS-based digital speedometer that I was going to take a picture of from my car. I have the only 1985 Pontiac Persienne with a digital speedometer sitting up on the dash. As most of you know, I authored an APRS client called APRS ISCE. That phone will quit ringing here in a little bit. And ported it to Windows 32, and I'm now playing around with one on Android. And you can see the dates that those things happened. But what is APRS? You've all seen this definition. It's a real-time tactical information sharing system. It has happens to do positions, but primarily it's about sharing information. It was developed by Bob Berninga, WB4APR, around 1992. And I don't know how many of you caught Bob's recent emails on some of the APRS SIGs. He's not only under treatment for cancer, but he now has COVID. So keep him in your prayers if you're a praying person, keep him in your good thoughts if you don't happen to be a person of faith. But he definitely could use all the supporting thoughts we can send his way. APRS is supported natively by at least 2 major radio manufacturers, Kenwood and Yaesu, as we all know. It's useful for both emergency operations and standard day-to-day operations. People ask me, why do you keep your trackers turned on all the time? I have a tracker in my car, RF. I have a tracker in my van that my wife drives, who is also licensed. I do it to make sure the infrastructure works. When Digipeaters are down, I happen to look at the track and find out, oh, my wife went downtown and didn't get picked up. Same reason we have nets is why we run our APRS trackers all the time, to make sure the infrastructure works. And one of Bob's famous quotes is, it's an example of highly successful integration of RF and internet technologies. We have the RF purists, we have the people that use the internet only. I like them both. They both have a way to fit. But what's special about the Golden Packet? It's a point-to-point linear line of 13 Digipeaters, plus the north and south endpoints for total those 15 stations that we're all familiar with. We use that alternate frequency on 144.340, and that custom path that works the magic of hop 77, hop 77. And that's really going to be the focus when we get into the meat of this. When you look at the map, the stations actually zigzag across the Appalachian Trail. Some people we talk to think, oh, you're putting stations on the trail. We're not. We put them on the peaks along the trail because we can take advantage of the altitude that way. And it provides a method of testing and validating a linear APRS link for emergency communications in a very scenic environment for most of the stations. So with that little bit of background, we're going to dive straight into the deep end, unless there's any questions about that simple stuff. AX25. Y'all have heard of AX25? It is the foundation of the APRS packets. The choice of AX25 governs some of the constraints that APRS lives under today. It's a link access protocol for amateur radio. We use in APRS the UI feature of AX25, the unnumbered information. If you're familiar with internet technologies, connected packet is like the TCP end, and the unnumbered information that APRS uses is like UDP. We throw the packets out to the radio. There's no acknowledgements. If it's caught somewhere, great. If it's not, we'll never know. One of the restrictions of AX25, every station has an ID. It's got up to a 6-character call sign and a 4-bit SSID. For those that have wondered, why in the world are we always talking about 0 through 15? It's because the actual SSID, the secondary station identifier, is stored in 4 bits. You can't put letters in there. You can't put numbers beyond 15. You never see -0 because -0 is usually suppressed when it's put out for human readability. But in actual fact, a station called KJ4ERJ is literally KJ4ERJ-0 because the SSID bits are all zeros. As we learned in December, AX25 packets strictly are based on checksums. They can detect errors, but they can't correct them. It's either all or nothing. You either get every bit correct or you don't decode the packet. Unless you have a TNC that you put into pass-all mode, but we're not going to chase that particular rabbit tonight. The actual AX25 packet looks like this. Let's see if I can do this right. Starts with a flag and has an address component. That's where the actual path goes. Has some control bits, has a PID, which is a protocol ID. The protocol ID for APRS, I should know this. I want to say it's F0, but I could be corrected on that. And then you have your information field. That's where all of your payload goes. You have that frame checksum. and another flag at the end. Inside that address is where you have the destination, the source, and all of the repeaters. And you notice I said destination, comma, source, comma, repeaters, because the order it is in the actual AX25 packet has the destination first, even though everywhere we ever see a packet has the source call sign first. Dates back from packet days.
So I'm sorry, so in the case of APRS, it's not destination first, it's source first, or?
No, APRS packets are standard AX25 packets.
Oh, okay.
So over the air, the AX25 packet actually has the destination first and then the source.
And question, and I'm pretty sure I know the answer to this already, but I read an article the other day and it mentioned APRS as a store and forward system, which as far as I know, it is not. So is that the case?
Actually, APRS is a store and forward, and I'm going to use those words very shortly.
Okay.
Because a digipeater is not like a voice repeater. Voice repeaters, when you're transmitting, it's simultaneously transmitting on the offset frequency. Digipeaters, digital repeaters, actually record the packet as they're receiving it, turn around and retransmit it at the end of the packet. Effectively a store and forward, but it's only stored for a short span of time until the frequency's clear again. We usually tend to think of store and forward as being like email. It stores it for a while and
Right.
forwards it later.
Yeah,
But
and I think that was the context the author was using it in.
yeah, that could be. But yes, normally APRS is not store and forward except for the way digipeaters work. Good clarification. Over the air, we know we use AFSK 1200 baud on 2 meters typically, 1200 hertz and 2200 hertz tones with that bit stuffing stuff that AX25 specifies that I've never understood. On HF, they use frequency shift keying with a 200 hertz separation between the mark and the space. I don't know what the over-the-air format is for 9600 baud. Does anyone know that actually? It's not something I've run into, and I didn't take the time to research it. There are other over-the-air formats that are used for APRS now. One of the hams in the UK wrote APRS Messenger that takes APRS humanly readable packets and transmits them out with PSK63 encoding. Whisper actually has a way that you can catch the whisper signals and turn them into APRS position packets. And the links are there in the slides for you to use later. But it's still all just error correction, still no error correction. It's just checksums. You have to get all of the packet perfectly before anything can be recovered from it. And that's where the guys that over at SCS came up with the SCS tracker, and they put forward error correction in their over-the-air protocol, primarily for HF, and you can read about those things at robustpacket.net. And then as we heard last month, the FX25 approach, paradigm, whatever implementation, puts a forward error correction wrapper around the AX25 packet. So it brings a level of forward error correction to APRS at the expense of longer packets.
Before you go on, Lynn, we talked about 1200 baud and you mentioned 9600 baud. Is 2400 baud also permitted? Is it for APRS?
As far as I know, there's no restrictions on anything you want to come up with. I have seen mention of 2400 baud and 4800 baud, but the two big popular ones are 12 and 96. I think mostly because that's what the APRS radio manufacturers are supporting natively. But just go ahead.
The logical follow-on question then is if one were using software like your software, where the baud rate is set by the computer, do you have the flexibility to use other than 1200 baud?
My software actually doesn't play with the baud rate. I rely on TNCs to do that.
Oh,
like
okay.
Direwolf.
The
So-
Direwolf software.
Yeah,
Because you
Direwolf
can
can
do
definitely
20
do.
Direwolf will do the 2400 baud.
Yes.
Thank you.
Yeah, thankfully my software is blissfully unaware of how fast the radio channel really is. Okay. So again, I'm preaching to the choir this, but to give a little background for those that might be viewing this later, on the RF side of the APRS infrastructure, we have Digipeaters, which are digital repeaters. We have both fixed stations like these houses over here and mobile stations that run around and move. But the simplex range for a mobile speaking to a mobile or a mobile speaking to a fixed station is only about half the range that you would get out of FM voice. That's a number Bob likes to throw around a lot. And it's because of that lack of error correction. If you have a single bit error in an APRS packet, you don't have a packet. And when you start getting a little bit of noise into your FM signal, if you get any flutter in your FM signal, you're not going to be able to decode the APRS. So about half the range of a voice repeater would be what you'd expect to get, or half the range of a simplex contact would be all you would expect to get on a simplex APRS link. So what you have instead, you have Digipeaters. You put them up high in some cases, you put them not so high in the case of a low level digi, and let them receive the packet from the mobile, retransmit from that higher altitude to get it back out to the mobiles that are not in simplex range. So just like we use our voice repeaters to reach people that we can't reach simplex, we use the Digipeaters to reach the people that we can't reach on simplex. Digipeaters are smart. There's no line here, but if this green star Digipeater could hear this green star Digipeater, you really wouldn't want this Digipeater to repeat a packet when he heard, like if the blue van here transmits a packet, it's going to be copied by both Digipeaters. If both Digipeaters act on it, then they may hear each other or not, but if they hear each other, you don't want them to retransmit the same packet a second time. So Digipeaters actually have built in a duplicate detection. Typically it's on the order of 20 to 30 seconds. And within that time, if they hear the same packet from the same source, destination, and payload, and I'll get to those three words here in a little bit, but the source, the destination, and the payload are all they look at. They ignore the path when they're doing their duplicate detection. They will only digipede a packet if it's different than any packet in their recent like 30-second memory. And that's how we avoid a lot of packet duplication. There's a slide coming up later that's going to highlight that there is a sort of a break. It's a practical break, but in implementation, I can see exactly why the programmers did it this way. The D710 will actually digipede its own packet, which you would think it wouldn't need to do that. It doesn't need to do that, but it does. And I can describe when we get over there why it does that. In the digipeating world, you have something called UI flood and UI trace. Those are words I'm sure you all have heard. Some of you may know what they are. Some of you are like, yeah, I don't know what those are. That's what we're going to talk about later. And then I just threw in two packets down here at the bottom to give you an eye test to see if you can actually read them. But those are APRS packets and what they would look like. On the internet side, and this is the only slide I'm going to talk about the internet side, is where the radio side meets the internet. iGates are on the radio side and on the internet side, and they feed the APRS IS servers. The servers distribute these packets globally, but it's not smart. There's a whole lot of people that think the APRS IS is intelligent, that it has routing ability, that it delivers the packet to the iGate that needs to know that packet. No. The APRS IS is simply a packet relay. Every packet that goes in goes to all the servers. Whether or not it goes out to a client depends on what that client's filter is, but all the packets go everywhere. It's not smart. And it's real time. Getting back to Jeff's comment about store and forward, the APRS IS is real time. There's no buffering. There's no storage on the APRS IS. APRS.FI is a completely different animal. It's simply a website that gets its information from the APRS IS. He stores stuff, but the APRS IS has no storage, no buffering. You tap into it and you're getting a flood of data. There is duplicate suppression again at the APRS-IS level, and this is why you cannot use the APRS-IS to evaluate RF coverage. You're going to see the first copy of any packet that was received by any iGate, and the rest of the copies that are flying around from Digipeaters and hitting multiple iGates, even multiple iGates in simplex range of each other. Only the first guy to gate it is actually going to be distributed through the network. Popular misconception is you can look at APRS.FI's raw packets and see, oh yeah, my packets aren't going very far. Look, it's always coming through that iGate that's right next door. Well, that doesn't count the digipeated copy that went to another digipeater that went to a third digipeater, and in the end hit about 10 different iGates on the way. So you cannot use the internet to look at the RF coverage. The APRS-IS, by default, and if iGates are designed properly, will gate messages back to RF from the internet for stations that they have recently heard locally. And it's up to the author to define what recent is and what local is. But typically it's either a distance or a hop count for locally, and recently is typically 30 minutes. But in addition to the message, you get something called a courtesy posit, which means if I'm sitting on the internet and I send a message to WB2OSZ, and he was heard recently by some iGate over in his local area, he'll get that message. And then the next time my station beacons a position, that iGate will also beacon that position out to local RF. And that's how you can find out if someone blindly sends you a message, the next time they send a posit, you'll get their posit automatically by the gating software. And some iGates beacon a lot more than that. It's usually user configurable. The specifications allow for any packets to be gated from the internet to the RF. But of course, a shared 1200 baud channel doesn't let you go very far. So that's kind of the background. And we're going to dive now into the anatomy of an APRS packet. We usually see packets that look like all of these, right? How many of you have actually looked at raw packets? Half of you, 3/4 of you, wonderful. So you've seen this. That's actually the humanly readable TNC2 format. It's been standardized. That is the actual format that the packets are in when they fly around through the APRS-IS. And it's typically listed as source call greater than destination call, comma, path, colon, payload. And sometimes, let's see if I actually included one in here. I didn't. Sometimes you'll actually see a packet that has a colon, colon. Well, that's because the first colon is the delimiter between the path and the payload. The second colon is actually the first character of the APRS packet, and a colon happens to be a message. An APRS message, the payload starts with a colon. So the path, the comma path, may be completely suppressed. If you're sending an APRS packet with no path, it only is copied by people within simplex. No digipeaters will pick it up. What kind of packets we have? We have position reports, including objects. We have telemetry and definitions of that telemetry, which are actually APRS messages. We have APRS messages and their acknowledgements. Message acknowledgements is actually just another APRS message with a special content. Bulletins are APRS messages with a special destination. We have weather packets, we have capabilities and status packets, and we have queries, and there's actually an entire range of experimental packets that software authors can use to play with other things. And there are a few things that use the experimental packet capability of APRS. So we have all these packets, and like I mentioned earlier, we have, if I did this right, well, there it goes. So that would be a source call, angle bracket, destination call, and over the air, that would have actually been transmitted as UR0PDO-0, SQ3GOK-9, wide 1-1, And the QAR and the SP3 KW8-4, we're not even going to get into. That's only on the internet side, and it's called a Q construct. You can Google that if you want to learn more. All the packets we look at off the internet are going to have a Q something on them, and it tells you things about the eye gates, not about the original RF side. You look on the RF, you'll never see a QA anything for one very good reason. You can't transmit a lowercase in a path component of an AX25 packet. So I guarantee you'll never see a lowercase QAR on the RF side. So that's the anatomy. We're going to focus tonight strictly on the path piece, the piece between the destination call and the payload.
Jeff, before you move on,
Yeah,
Yep.
could you go back there? I'm sorry, I was talking to Lynn. I beg your pardon. Your example that you highlighted, the destination call was a actual call sign. The next line down, the destination call appears to be APESPG. What is the derivation of that?
Okay. Destination calls are really only used as destination calls for packet operation. APRS overloaded the to call or the destination call with one of three things. In the example of that first packet, that UR0P90 is probably not a call sign.
Ah,
It is probably part of the latitude or longitude of a MIC-E formatted packet. MIC-E is a format of compression of the latitude, longitude, altitude, speed, and heading that actually Kenwoods and Yaesus prefer to transmit their locations in MIC-E, but they actually put a portion of that information into the destination call. And I don't actually support that in my APRS packet building because I think it's rude, obnoxious, and it's very hard to read. The next one down, the APESPG, is what APRS calls a to call or an application identifier. Anytime you see greater than AP, it is probably an identifier for the software that generated that packet. In the third one down here, you notice APU25N.
yeah.
I happen to know that is UI view 2.5. APN 383, don't know what that one is. APOT30 is an open tracker.
So it can be vendor specific, you're saying?
It can be vendor specific. Yeah. Let's see if I can actually manage to pull. No, I don't have an easy way to do this. If you Google to-call, TOCALL space APRS, you'll find the page that is tocalls.txt, and it lists every single one of the to calls that have been granted by Bob to applications and hardware. Oh, that last one down is a really good one. APDW12. That is literally direwolf. I happen to have looked that one up recently.
Okay.
Link in the chat.
Oh, great. Excellent. So if you click on that link,
now, Lynn, you mentioned the QAC, QAR only is an internet piece.
that's
But
correct.
I have an RF only Digipeater running as part of a test environment. And it is seeing those codes coming from iGates, even though it's on RF only.
Yes, I can believe that because what it is probably seeing is a third-party packet. When an iGate relays an APRS IS packet to local RF, it doesn't just transmit the packet as it stands. It actually wraps it into a third-party format. The source call on the third-party packet is going to be the iGate call sign. The path is going to be made up by the iGate. The payload is going to be the entire APRS IS packet, including the Q codes, the Q constructs. So if you look close at where you're seeing Qs on your RF side, They're actually inside the payload of a packet.
All right, I'll go check that.
Yeah, because like I said, you can't put a lowercase character into the path of an AX25 packet. So I guarantee they're not in the path of the AX25 header.
Yep.
And I believe the third-party identifier, I think, is a hashtag, a #, tic-tac-toe table.
Lynn, the pathing, the first line has the wide 1-1, and then we see like TCP/IP star, we see a D star, and we see DMR star. Can you tell us about those?
Yes. These packets, as I mentioned, I captured off the internet. So the wide 1-1 is what you would have seen on the RF side. And the QAR code after that one actually means it was received by the iGate called SP3KWA-4. So that would have been the path as originally transmitted by SQ3GOK. The TCP/IP star, the HS5 NFP station, is directly connected to the APRS-IS. He generated that packet himself, which is why the TCP/IP star is in there, because that is a packet created and originally injected to the internet. The QAC means it was received by the Tier 2 Thailand APRS-IS server. So HS5 NFP directly logged into the APRS-IS and is injecting his own packets there. The D star is probably coming from, what's it called? DPRS, which is an adjunct you can hook into your D star repeater that captures the position information from D star, translates it into an APRS packet, and injects it directly into the APRS-IS.
Same for DMR too. They both support DPRS.
Okay, right, because they're both grabbing it off of a digital system, and I'm sure that it was originally written for D star, and DMR, I'm sure, adopted it. Although this one down here, might that actually be the DMR version of DPRS?
It may be the DMR version of it, but yeah, it's still considered DPRS in the DMR world.
Okay.
It has to be, I mean, so in order to route it between bridges in the DMR world, it's going to need to be distinguished from DPRS.
Right. And you notice after the Q construct, we're actually allowed upper and lower case in your call signs. And in fact, you can do upper lowercase anywhere in your APRS-IS packet, and it's totally legal. You can do alphanumeric SSIDs on the APRS-IS, and it is totally legal. And I can sit here on the APRS-IS side with a station identifier of KJ4ERJ-AP, Alpha Papa, and I can send messages that go out through an iGate and get to a Kenwood APRS radio, and he will receive my message, acknowledge my message, and be able to reply to me with a non-0 to 15 SSID. Because everything about APRS messaging is over in the payload. It's not in that AX25 header. Yaesu's implementation of messaging doesn't do that. A Yaesu will not receive, nor will it ACK, nor can it send to an alphanumeric SSID, even though it is totally legally viable in the APRS spec, because the destination of a message never appears in the AX25 header. The source of the message does, but when the message goes through an iGate, the source of the third-party packet is the iGate. He has to be AX25 compatible, but the message itself goes in the payload. So Yaesu has a bug in their messaging. They can't handle alphanumeric SSIDs or anything but 0 to 15. But we're not here to bash Yaesu. We're here to dive further into the APRS packet, unless there's more questions on this one.
Lynn, Dire Wolf actually drops lettered SSIDs as well, I think.
He should, yeah.
As I look at their messages in their log, they show that the packets were letters instead of numbers, and they dropped the packet.
Oh, they dropped the packet.
That's what the message says.
That's rude.
Yeah,
'Cause there's absolutely no reason they cannot gate that to the RF, because they're supposed to gate it with a third-party packet where the entire packet's in the payload.
Okay, this is John WB2OC. Contact me directly and we'll evaluate what's going on.
okay, thank you.
Yeah. So you can interpret the log for them.
Apropos our ATGP, if I were transmitting a packet from Mount Washington, would the first beginning of the message be my tactical call or my real call?
Very good question. And in fact, there's a defect in a slide coming up later. And if you help me remember to fix it, when we start talking about the configuration of the status reporting and update it frequently, we need to put our actual FCC call sign in there as well. Because what will be in here is MTWASH-13 or 14, you're 14. So the header, the source call sign will be your tactical call that we program in as my call in the radio. And you need to put your FCC call sign in there somewhere else to meet the licensing requirements in the United States.
It could be in the body, the message body, right?
Yes, and when we get to the slide that has the defect, it's where I'm talking about updating it frequently to show your status to the other stations. We need to fix that and say, put your call sign in there as well and keep it there. Because that's actually not in Bob's setup instructions. I realized that when I was going through this right before starting tonight. So
So in the
Excuse me.
case of a beacon packet coming from me on Mount Washington, it'd be have MWASH-14 or whatever. And then after that greater than sign, it's a beacon, so it's not directed at anybody, right?
it's going to, because you're on a Kenwood D710, you're likely transmitting Mickey encoded packets. So after the greater than is going to be some random string of characters
Gotcha.
that actually is part of your lat long.
Got it.
But go on. And then it's going to say comma, hop 77, comma, hop 77, colon, and then it is going to have this little backwards tick right here, and some other seemingly random characters that is the rest of your lat long encoded. And your symbol and your table is in here somewhere. I think it's right in there. And then the rest of your comment is going to be after that. And that's a Mickey packet. And the coolest feature that APRS.FI has is go to their raw view, look up your station, it's a D710, and then tell it you want to see the decoded flavor. And it shows you the original raw packet as well as the full parsed breakout of what all it meant. I use it a lot. So like I said, we're going to focus tonight primarily on the path piece between the destination call and the payload. The path, as we all know, it's where you put a service request in for the Digipeaters. It goes between the That's the feature. There are special paths that you can put no gate or RF only. They're supposed to mean the same thing. Not all iGates implement them, but if you put that anywhere in your path, the iGate is not supposed to gate that packet to the APRS IS if it's received. Like I said, some iGates don't implement that. You can see TCP/IP star. We saw that in some of the packets. Those are APRS IS originated packets. You might see TCP/XX star, although that's a very obsolete path component. So what kind of paths do we actually have? Now that we know what we don't have, we have relay wide. How many people have played with APRS back when relay wide was actually used, before the new paradigm? I count
Nope.
myself out of that as well. It has serious problems because you can't easily stop it in its tracks. If you wanted to go 3 hops, you would put relay, wide, wide. And when the first wide digipeater heard the other wide digipeats digipeat, it didn't know if it was supposed to keep repeating it or not. Digipeaters sometimes didn't mark their used bits in the right places, and they had packets from anecdotal stories I've read hopping 15, 20 hops out before they would finally die. So enter the new paradigm, the wide N-N paradigm, which is what we're all familiar with. Okay, why won't my pen let me erase my ink? Thank you. So the wide NN paradigm, we're used to seeing the wide 1-1, wide 2-1, wide 1-1, wide 2-2. If you're a little bit further out, you can even use a wide 2-1, which is preferred for fixed stations where you don't need the assistance of a low altitude digipeater. That's the general idea of that. Wide 1 is for low altitude digipeaters. Wide 2 is for the higher up digipeaters. All the wide 2 digipeaters are supposed to honor the wide 1. The wide 1s are only supposed to honor the wide 1s in a properly configured network. We also have SSNNs. Do any of you live in an area that actually uses the statewide coverage aliases? No? I've seen them every now and again. I've seen it in a packet, but every state actually has their own little thing. Some states are split up into multiple regions. Like here, I'm actually CFL N-N. And theoretically, I can put a CFL 2-2 in my packet and it will digipeat around Central Florida. It will not go out to the Panhandle and it won't go down to the Keys. That's the theory. I don't know if digipeaters are actually configured to honor that, but that's going to come up again when we start talking about UI flood and UI trace. And then we have our favorite, HOP77, the AT Golden Packet path alias. HOP is nothing different than SS, is nothing different than wide. It's just another alias. Bob could have chosen ATGP 7-7, although that's a lot harder to say than HOP77. There's nothing magic about HOP. It's all in what we're configuring into our digipeaters and in our paths. And most of you probably know you can configure an explicit call sign SSID into your path, and that's requesting the service of a specific digipeater. No other digipeater should act on it. And if that digipeater doesn't hear it, then that packet's not going to be repeated anywhere. So that's the paths and the aliases that we put inside our paths. Now we're getting deeper. We've got the path that asks for the digipeater service. Now we're getting to the digipeater itself. We know a digipeater is a digital repeater, but it's not concurrent, like I mentioned earlier. It's not like voice. It is store and repeat. I was wrong, Jeff. I didn't call it store and forward. I called it store and repeat, just to avoid the confusion. So it does store it because it's got to get the whole packet before it can retransmit, but then it immediately repeats it. It doesn't do it simultaneously because it's a single frequency. And this is a big one that in my APRS client support, I get asked this a lot, and I'm sure John fields this question every now and again. Why isn't my digipeater working? Why isn't my digipeater working? My car is beaconing and my digipeater's not picking it up. Well, a digipeater can only repeat what it receives and decodes. So the first question I always ask them is your digipeater even decoding your car? Because if it's not decoding your car, it's not going to repeat your car. And a single bit error, like we keep talking about, that packet didn't exist. So you have to be able to decode it, receive it, and decode it in order to digipeat it. The second most popular thing is digipeaters act on the first unused path component. Now, when I say unused, if you remember back to those packets, let me go back here. we see all these little asterisks floating around. Got an asterisk there, we got an asterisk here, we got an asterisk here, but we don't have an asterisk on the wide 2.1. So if a digipeater heard this packet, he's going to ignore the K2PUT-15 because that has the used bit, that little asterisk. He's going to look at the wide 2.1 and decide if he should digipede on it. This first packet, he's going to see the wide 1.1, decide if he should digipede on it. This one, he's going to see the wide 1.1 and the wide 2.1, but he's going to look at the first unused component and he's going to act on the wide 1.1. So digipeaters act on the first unused path component. Almost, because there are some digipeaters that support something called preemptive digipete, and they will act on any path component regardless of where it is relative to the last used bit. So you could actually construct a path like wide 1.1, wide 2.1, comma preempt, where preempt is just an alias for whatever we told our preemptive digipeater to trigger off of, comma wide 2.1. The preemptive digipeater will see, oh, look, that's my word out there. He'll use that one and then proceed to retransmit the packet with a wide 2.1 left over at the end. The Tracker 2 family of TNCs supports preemptive digipeating. They'll even support preemptive digipeating of a specific call sign. Really handy when I'm out hiking with my D74 and I've got my van parked out there with its T3 135 under the driver's seat. I can set my HT up to hit the van's call sign and then let the van beacon out the wide 2.1. My HT can't get out, but my van's got a nice 2-meter antenna sitting up on the roof. Very handy for preemptive digipeating. As far as I know, Kenwood doesn't support that in their APRS radios. And digipeating is always based on either an explicit call sign SSID or a configured alias. For example, wide, temp, or hop, but it's whatever you want to configure in there. And in fact, because if we go back to our AX25 slide, it mentioned the path components are 7 bytes each. It doesn't matter if the alias is hop or if the alias is wide. They both take 7 bytes for each entry. So you can't decide, I'm going to make my packet shorter by using an alias of A. Doesn't work. It's still going to take 7. It becomes A space, 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 dash SSID. Thanks to AX25. So digipeating is always based on that alias or a specific call sign. Now we're going to dive into the actual specifics of digipeating. And I'm almost out of time, right?
Keep it going.
So
Yeah.
Explicit digipeating is easy. You mark the component used and retransmit. Explicit is they asked me to do the digipede. New NN is almost as easy. You decrement N, mark it used if the N is now 0, and then retransmit it. You retransmit it if it's 0, but you mark it used if it decremented to 0. The big question, the big variable is, what do I do with the previously used components when I digipede it? All those ones that were before the first unused. Like if I've got Digi1, wide 1, Digi2 used, wide 2.1. If I decrement the wide 2, it becomes 0. When I repeat that, do I repeat it as Digi1, wide 1, Digi2, Digi3, wide 2 splat? Or how do I digipede it? And the final variable is, do I identify myself or not? Does the digipeater insert its own call sign in the repeated packet? Those are the variables that we configure into our HOP77 digipeaters for ATGP. I listed this for an interesting reason, because you'll see packets written both ways, depending on who generated the packet. And in fact, John, you can probably back me up on this. When you receive packets over the air, sometimes all the first parts of the paths are marked used, and sometimes only the last one is marked used. So in the first case here, the Digi2 is marked used. It implicitly means Digi1 and Wide1 were used. Some Digipeaters and some TNCs will actually set the used bit on all three components. And it's up to, I guess, I have not found a good specification for what that means or whether it should be set on these early bits, but definitely you're looking for the last marked used. So the first unused is what the Digipeater is looking for. And so for explicit digipeating, if the Digipeater receives a packet that says source comma destination KJ4ERJ-5 wide 21 with the payload after the colon, I'm going to add the used bit to my call sign and transmit it. So the only thing I did to that packet is I changed my explicit call sign to be marked used. In the D710, this is actually done in menu 616 for Digipeat of my call. And for Appalachian Trail Golden Packet, I'm going to get to this later, but that is actually enabled for Golden Packet. So that's explicit digipeating or digipeating on my call. UI Digi flavor. I did not know about UI Digi until I read how to set this up when preparing this presentation. I'd never heard of UI Digi. UI Flood, UI Trace, yeah, UI Digi. UI Digi is rude. I'm glad I never heard of it. If you receive wide 1.1, wide 2.1, and you have your UI Digi configured for wide 1.1, you replace the entire alias with your call with a used bit and retransmit it. So you totally lose the fact that there was a wide 1.1 in this packet to begin with. And all you see is the Digi. Really rude, but I understand that some of the KPC3 earlier firmwares didn't really know how to do wide 1.1s properly, and they used this kind of an approach for doing the unnumbered information digipeating. We don't use this for Golden Packet, but you'll see it in your setups, and we disable it for the Golden Packet. UI Flood. UI Flood is a very common digipeating practice. There's two flavors of it, supported by the Kenwood radios. If you receive the source destination wide 1.1, wide 2.1, the rule is you decrement the N, mark it used if it's 0, and you insert my call. And that gives you this packet. And you can tell from this packet that KJ4ERJ-5 acted on it, and he acted on a wide 1, presumably a -1 because he decremented it to 0 and marked it used. And there's still a wide 2.1 left. But if that same Digipeater receives something that was already, if a different Digipeater receives that digipeated packet, he's going to decrement N of the first unused piece, mark it used if 0, remove the unused components, and insert my call. Wait, remove the unused components. Remove the used components. Read what it says. He's going to end up transmitting this. So if KJ4ERJ-6 copies the KJ4ERJ-5 digipeated packet, he ends up transmitting the fact that I did this, it was a wide 2, apparently -1 because it's marked used now and I decremented it. So you lose the traceability of how the packet got to KJ4ERJ-6, but you get to see who last acted on it. This is UI flood digipeating with a substitution of ID, and it is exactly what we use for the AT Golden Packet with the hop alias. We get rid of everything that was used to date, we put ourselves in, and what's left of the path. So we do UI flood digipeating. The standard for the state abbreviations is also UI flood, so that we don't grow the path length. I'll get to that in a little bit too. UI flood flavor 2 is if the first digipeater marks this, the rule is decrement N and mark it used if 0. And that's all he does. And when he transmits this back out, you cannot tell what digipeater did that because he did not insert his call sign. He simply decremented and marked it used. When another digipeater hears that original call, the one that was done by the UI Flood Flavor 1 over there, he's going to transmit it out this way. And you've got no clue what Digipeaters handled that packet. But that is exactly what UI Flood Substitution No ID does. It hides everything that went before. And that's what UI Flood does. Substitution No ID says, don't even tell them who did it. So you can imagine a network with one of these Digipeaters floating around in it will drive you nuts trying to figure out where the packets are going and coming from. So we don't use this one on Golden Packet either. We use the substitution ID. UI trace is the normal digipeating that we see on the normal APRS national network. The rule is you decrement N, mark it used if 0, and insert my call. And if you get one that already has stuff used, you do exactly the same thing. There's no removing of anything. So we're going to digipeat the fact that ERJ-5 handled it, mark the wide 1 used. We're going to mark it that ERJ-5 did the wide 1 and ERJ-6 did the wide 2. And the packets get longer. It is completely traceable. When we only need to go 1 or 2 or 3 hops, it's gorgeous because it really doesn't make the packets that much longer. It's 7 bytes for each one of these components. But it does make it longer. This is what we use for the temp alias on the Appalachian Trail Golden Packet. And it's what is used in the APRS National Network with the wide alias for the new paradigm digipeating. So digipeating Appalachian Trail Golden Packet style. Starting from AO Mountain, I just pulled that one off the top. AO Mountain transmitted this packet. It happens to be a bulletin number 0 with an extra text of AO Mountain. The text of his bulletin is hearing 3 to 9. He's transmitting it, that application identifier. A K102 is a D710, G. A K101 is a D710A. Hop 77 is the path that we all configure into our radios. So we're sitting here at AO Mountain and we transmit that packet with a hop 77. My south partner and my north partner, if all is working well, copies that packet. With their UI Flood Substitution ID configuration of a digipeater, Commerce is going to transmit it with Commerce 4. At the same time, Hawksbill 6 is going to transmit it. Both are saying hop 7-6. They decremented, didn't get the 0, so they did not mark it used. They inserted their Digipeater's call sign. When Roan copies Commerce, he's going to do the same thing. He's going to look for the first unused. He finds the hop 7-6, decrements it by 1. It's not 0, so don't mark it used. Replace everything that's used to date with me marked used. Same time it's gone up to Maryland Mountain 7. Klingman copies Roan, hopefully. GD Hill copies Maryland Mountains, gets the whole way down to Springer, and it's got a bunch of hops left by the time it gets to Springer. On the north side, goes to Camelback, goes to Sam's Point, goes to Greylock, goes to Equinox, comes through John sitting up there at Mount Washington, and at Katahdin, he would actually receive a packet that says Mount Washington 13 splat, hop 7-6. He does not know that there was originally a hop 7-7 before that hop 7-6 that's left over because of the UI flood replacing all of the previously used hops. You'll notice that happened right here at Mount Washington because Equinox said hop 7 star, hop 7-7. Mount Washington hid all that history and said all that's left is a hop 7-6. That is UI flood substitution ID style. If we did this with you,
why is AO Mountain considered dead center then if there are 8 points north and 4 points south?
AO Mountain's not the center. That's just the one I pulled off the map and made my example packet for.
Okay, yep.
I have a better slide that shows who's the middle. It's GD Hill.
GD Hill, okay.
Which is why he's number 8.
So Lynn, when Tim gets that on Katahdin, he's going to digipede it as well, because he's going to take that hop 7-6 and increment the 6 to a 5.
That's correct. And he'll put Katahdin 15 in.
Okay, obviously the ands digipeating serve no purpose for us, right?
Unless we got the guys in Canada mobilized, they're counting on hearing Katahdin.
Okay, okay.
But the key is the Springer packet that started out as a hop 77, hop 77 isn't going to make it out of Katahdin. So the Canadians are not going to hear Springer. The second Canadian is not going to hear Klingman's because it's going to run out of hops before it gets to him.
Wait, that packet, oh, yes, sorry.
Hey, Lynn, is the 7 the highest you can go?
That's a really interesting question. One would think that can go to 15 because it is actually just the SSID. It's that same thing that's encoded in the 4 bits of the AX25 header. But I think we're actually limited to 9 because I think it looks at the number after the alias, the first number in the alias or the last digit. I don't know.
I'm just wondering, because if you can go to 9 in theory, that one that you said would not make it into Canada could make it into Canada then, right?
Yes, but there's an easier way to get that one into Canada. Anyone want to guess what it is? We talked about it already.
Add another hop 77.
Bingo. Hop 77, hop 77, hop 77 on the originating packet. It's going to try to go 21 hops.
Now, there was concern about the packet header becoming too large by doing that, right?
The packet header gets 7 bytes bigger. Wow.
Okay,
You know, I mean,
right, but I'm saying, like, I thought when we discussed this back in August, though, that there was a conscious decision to not do that because
There
of
is.
the increased size.
there is, but if we can educate enough of our stations to understand what these hop 77s are actually doing and get people to not follow necessarily a cookie cutter configuration of their station, but to plan it accordingly, Springer and Klingman, and possibly Roan, depending on how far out the north end we want to go, could use a 3-part hop 77, hop 77, hop 77.
Okay,
Cummers, AO Mountain, Hawksbill, Maryland Mountains can use the hop 77, hop 77. GD Hill actually today only needs to use a hop 77 to get to Springer and Mount Washington and Katahdin. He would only need the second hop 77 to get further north or further south.
okay,
So it depends where we want to go, how much we need to put in our path. If we're only trying to go out the north end, it's only Springer, Klingman, and Roan that need the extra path component on their packets. Everyone else can just run with the 2 hop 77s. Sweet.
so.
Thank you, Lynn. I now understand the hop 77 issue. Thank you.
So, yeah, it's a question, I guess, I mean, it's tactically how we could plan this out for this summer. If, to John's point, right, we set distinct or discrete, start time, end time for different exercises, start at 1200, at, 1300 hours, we switch to 96, just as an example, right? I mean, we could talk about at fixed time intervals that we make modifications to path as part of this exercise, right?
Absolutely.
Okay,
100% right on the money.
okay,
Now, this is all UI flood substitution ID. If this same packet was transmitted in with UI trace digipeaters all up and down the trail, what eventually gets to comes out of Springer would be this packet. Let me get rid of all my ink and just highlight the one. This is what Springer would end up transmitting. That's a lot longer than what Springer really did transmit. And the real killer is what Mount Washington would have tried to transmit to get up to Katahdin. He would have had all of this. This is why we use UI flood, not UI trace for the golden packet, because we are trying to go lots and lots and lots of hops. This is what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 path components. I meant to try to dive into the AX25 book, but it has been a decade or two since I actually studied the AX25. I don't remember what the limit is on how many path components can be in the AX25 header. It might only be 8. Don't know. But if we tried to do it with tracing, our packets really would be growing as they traverse the trail. So before I dive into the next whole topic, which is going to go a lot faster than what we just did, because this explained it all. And the rest of it is just, how do we make all that happen? So are there any other questions on the actual digipeating and the hop 7.7s and how all that plays together?
Yeah, I have a question, Lynn. This is John again.
Okay, go ahead, John.
You said the word hop had no meaning. It could be an XYZ, right?
That is absolutely correct.
Okay, that was my question as well.
I'll show
Yeah,
you
it
the
just
two
seems like it
places.
just needs to be common across all the devices.
Okay, so we're using hop 7-7, but what's the purpose of the first 7? Could we have just used hop-7 and it would have worked just fine?
If you remember, the new paradigm is called wide N-N, where the first N is usually printed lowercase and the second N is usually printed uppercase. So the N after the dash actually gets decremented as it goes.
Right.
And the theory of the first number before the dash is it's supposed to represent how many hops were originally requested. It actually doesn't mean that, because if I start with a wide 2-1, I'm not asking for 2 hops from the get-go. I'm actually asking for a high altitude digi to do it once. So the first number, as far as I understand, for the way aliases are recognized for the new N paradigm, it has to be a number there, but I don't believe that number is used. And you can actually test this yourself, because you can put in a packet wide 7-2 and it will probably get digipeated twice.
But on our radios, if I just put hop-7, would the 710 digipede it?
I don't know. I would be surprised if it would, in actual fact, because it's
Okay.
using the temp N dash, the wide NN paradigm, and it's not seeing that first N to recognize that it's actually the alias.
Now, you mentioned that the 2 is a high altitude digit. When you do wide 2-1, the 2 represents a high altitude digipeater where a 1 was a low. Does the digipeater know whether it's high or low?
By configuration only.
Are there some digipeaters that will ignore the 2 part because you showed how it processed these, looked at what it had, the asterisk to know what it has acted on. Are some smart enough to know that they're not high, so they shouldn't act on a wide 2?
Yes, low-level digipeaters are supposed to be configured to only act on wide 1 and ignore wide 2 if that is the first unused path component.
Okay, I know this is slightly off topic here, but could I set is there some way I set my 710 to tell it to ignore the 2s because it's only a 1?
You would use the UI digi and set the alias to wide 1-1, and you would disable the UI flood and the UI trace. And then your
Okay.
D710 would only digipeat if the first unused path component is wide 1-1.
So are we doing something similar? So our 710s only digipeat if the first unused path component is a hop 7?
Yes, because we're configuring the UI flood with an alias of hop. It
Okay.
will actually digipeat any numbers, but the magic is the hop.
Thank you.
And Ron, I think you had a question also?
Yeah, it's 2, they're really easy, quick. So, so when you said with the 3 stations in Canada, The only one, and for it to go north, you would need the bottom three to have the third 7.7. And then if you wanted to go from Canada back down, those three stations would need the third hop 7.7 as well.
Yes, the ones up in Canada.
Okay, then the other question is because I think what John was asking about that first 7. So this is just for me, everybody else can ignore it, but in theory, you could put any number in there first. It's like a hop 3-7, and it would still do the same thing.
It'll still go 7 times, yes.
Yeah, all right, thanks.
But you can also start with a hop 7-3, and it will only go 3 hops.
Yeah, the important hop one is the second one. The other one's kind of like a space filler.
Yeah. that's
Almost.
what
It
almost,
doesn't work. Yeah, but with the wide, it's different, but for this, okay, got it, thank you.
Yeah, and in actual fact, you can do crazy things. You can actually put a packet that says wide 2-7. And there's a lot of Digipeaters out there that will actually make it hop 7 times. Because they're decrementing what's after the dash. And they're not really looking at what comes before the dash, except for the low-level digis that are only sensitive to the wide ones. Just remembered one other thing I wanted to mention on this slide. And that is that packet right here in the middle. AO Mountain 5 splat hop 7.5 hop 7.7. This is the D700 D710 Digipeater bust, which is not actually a bust. It's just kind of a mysterious oversight on behalf of the radio implementers. AO Mountain 5 transmitted the original packet out with a hop 7.7 hop 7.7. If he copies back either one of these 2 packets, if he copies back the Cummers 4 packet or the Hawksbill digipeated packet, he will see the first unused path component is hop 7-6. He's configured to do a UI flood on alias hop. He decrements the 6 to a 5. He checks to see, have I recently digipeated this packet? And that's the key phrase. Have I recently digipeated this packet? His answer is no. I have not digipeated a packet that says AO Mountain 5 APK 102 bulletin here 3 to 9. I have not digipeated that packet. Therefore, I'm going to go ahead and digipede it, even though it was my own packet, because that's not part of the rules of digipeating. They can fix this if they would take the original packet, this big one, and put it in their Digipeat table to say, I have transmitted this packet. Then when they hear one or the other of these back, it'll be in their digipeated thing, which doesn't really mean I've recently digipeated. It means I've recently transmitted this packet. And they could prevent this bogus re-digipeat of their own packet. But you will see these packets. When we first discovered this, it drove us nuts because we could not figure out how we got a 7.5 used by AO Mountain 5. Somebody was going to say something in there.
I was going to say, I've seen other implementations that also do this.
Yeah. And it's simply because they did literally what the Digipeat duplicate says and says, have I digipeated the packet?
Yep.
When in fact, I think the question should have been, have I transmitted the packet? And they should be keeping track of the packets that they're transmitting for any reason to avoid redundantly digipeating. I mean, it's the same blooming transmitter that did the original packet. They think the digipeat's going to go further. I find it humorous. I'm glad I didn't write the code, but if I wrote the code, I'd be poking fun at my own code as well. So that is the Digipeater bust on the D700 and D710. Don't be alarmed if you happen to see a packet ripping around like that. So unless there's any other questions on digipeating, I don't want to pull ahead too fast, but I also want to finish the rest of these slides.
Yeah, we've got quite a bit more to go through.
Yeah, but it'll go pretty quick because now we're going to dive into the Golden Packet radio settings. Why do we do what we do when we set up these radios? And how does that tie back to all that knowledge we just got? Primarily, the things we're going to set is a my call, the data band, the location, the comment, the symbol, the TX timing, the path. Oh, the path. Wow, we've heard of that. and the Digipeat, which is the whole point of this station. So those are the ones we're going to talk about. My call is easy. You configure who you are. The north side, GD Hill down to Springer 1, and that's the south side. The north side is Katahdin 15 the whole way down to GD Hill 8. You notice GD Hill 8 is in there twice. That's why he really only needs to do a hop 7. He doesn't need it in there twice to get to either end of the chain, because he only has to go 7 hops in either direction. So
Lynn, we don't have Sugarloaf anymore.
I know.
Are we gonna renumber on the north end?
I will leave that to powers beyond me. I don't feel a particular need to renumber.
What was the question?
Sugarloaf 14, we don't use that anymore.
Right.
So in other words, we go from 13 to 15. Theoretically, Katahdin could be Katahdin-14.
So actually, yeah, these numbers are not accurate based on what we actually used this past year.
That's correct.
Right.
We haven't used Sugarloaf in a few years.
Yeah, so Mount Washington was actually 14 this past
Nope.
summer, and Katahdin was 15. And that
No,
was
Mount-
I
because
thought Washington was,
we had
I'm not
added.
sure. I'd have to check.
Can I
Isn't
finish?
Washington still
Can I
13?
finish, please? So we had added Bovina 11, which replaced, so we went from Camelback 9, Sam's Point 10, Bovina 11, Greylock 12, Equinox 13, Mount Washington 14, and Katahdin 15. So there was a renumbering this past summer.
That my
I'm
slide does
sorry,
not
Jeff.
reflect.
Maybe we just need to update this slide.
Yeah, it's just that, yeah, the slide, I should have caught that when, yeah, when we we're going through. I can fix that, tweak it, and we can send out a revised version before, I'll revise it before we post this.
Very good. So my call is pretty obvious. It's who you are. My map, you'll notice I don't use the dash numbers. I use a GP dash. That is simply to make it easier to find my objects because they have a shared prefix, because nothing in the APRS lets you say, search for everything with this suffix. But there is a way you can search for things with a prefix. So that's why I drop the numbers and I just put GP dash instead for my objects. So in my call, the intent behind configuring the my call is to identify the station and via the SSID, your position in the chain. D72s to D710s, D710Gs, exactly the menu that you do that in. These settings, by the way, were taken directly from Bob's Golden Packet settings that he has out on the APRS ATGP website. He just doesn't say why we're doing it. The data band is where we're going to put the 144.340 frequency. We use APRS on band A and keep band B for UHF voice. This is strictly by convention. There is no magic to say APRS needs to be on band A and UHF needs to be on band B, as far as I know. But it makes it easier for all of us to configure the same radios, especially on me, because I can ask, is your A band set to 144.340? Instead of needing to say, what is your APRS band and it is set to? You do this with menu 601. You put your data on the A band. This is where you also set the 1200 baud. And there's an inconsistency on Bob's website. The D710 doesn't talk about 9600 baud. The D710G mentions later 96. And DCD sense is another important parameter that doesn't get a whole lot of stress. This is where the Kenwood APRS TNC is going to look to decide, is the channel clear for me to transmit? By setting it to D or RXD band, it's only going to listen to the data band for a closed squelch to decide it's allowed to transmit. You can set this up so that if either band has open squelch, it won't transmit, and it will drive you nuts. If you're listening to a rag chew on the repeater, or you're chatting up a storm on the UHF, your beacons aren't going to be going out because it's waiting for the other channel to get idle. So DCD sense is really important, and it's a real popular thing to have wrong and make your APRS station not transmit. 200 milliseconds is the default for the transmit delay. That's that front porch delay that we talked about, that I mentioned last week, for stuff that gets added on the front of the packets for timing purposes. Location, this is just where you are. It's recommended we configure a static location. We do not require GPSs. In fact, it's easier if you don't have a GPS, because that way your station's not moving around a little bit with your GPS drifts. So that's why the recommended settings, even on the D710G, is turn your GPS port input off and manually put in your lat lon. And you get it to use your location by pressing the use button on your radio. You need to have an asterisk by the lat lon that you're actually going to use in your packets. Lets you put up multiple locations in your radio and then toggle between home and your hunting camp and your golden packet station. Menu 606, we also turn the speed, the altitude, and the ambiguity all off. This is to shorten the packet. We know you're not going to move around up there on the top of the mountain, so we don't need the speed, altitude, and ambiguity in your packet taking up space. The comment. Okay, this is something about Mickey that drives me nuts as well. There's a comment, and then there's a status text. And people always are wondering, how can I specify a custom comment? Well, you can't. In the Mickey protocol that the Kenwood radios and the Yaesu radios use, there are bits, there are three, oh, John, help me, is it 3 or 4 bits for Mickey status?
I don't remember. It's been so many years. 3 or 4.
Okay. It's Mickey, 3 or 4 bits.
But Mickey format is stupid and no one should use it.
Yeah, it's either 3 or 4 bits,
It's
and
3.
it simply maps to your, it's 3? Okay.
Yes.
So, but I thought there were 7 different specials.
I am looking.
This
It's
is where you
taken
set
a really
your
long
in,
time for the site to come up.
yeah, you can put in transit, idle, en route, couple of different things you get to choose. That's in menu 607. And the recommendation there is just set it to special. And that's just picking one from a list. There are also custom settings that you can set, but the custom settings literally just say custom 1, custom 2, custom 3, custom 4. And it's up to the event that's using these Mickey settings to define what those mean, but you'll never change the text that anyone sees for their Mickey status. And there is one special Mickey value, which is all bits set, that means emergency. And all APRS clients are supposed to act on if they ever receive a Mickey emergency packet. And that's where that happens. But at least the radios warn you if you pick emergency. Menu 608 is the one where you get to put your own text in. Recommendation when you're at the ATGP event is you put your call sign in there, and that's what's missing on this slide. So Jeff, if you can make a note that slide
Yep.
25, we need
Slide
to put the call
25.
sign in here in 608.
Okay.
You put your call sign in there, and you can put in there, encoded however you wanted to put it in there, what stations you're copying. What's nice is that comment goes out in your beacon packet, so everyone else can look at their list and immediately see Mount Washington is seeing from 9 to 15. Springer is seeing from 4 to 1. Hopefully he sees 1 since that's him. So I really encourage you operators to play around with menu 608, play with how easy it is to set the statuses. I find it very easy to do with the microphone that won't go into focus unless I put it by my face. With the DTMF microphone on the D710, you just key in the letters and numbers and set your status up that way. The TX rate is also important, 1 out of 1, because otherwise only every N packets will actually have your status in it. And you really want that status to go out with every packet, because that's how we're communicating up and down the chain. We're going to take the airtime anyway. We might as well put information in there. The symbol, recommendation in all the configurations is to make it a tent, except for the D72, which says you can use a human or a tent. My opinion, you can pick whatever you want, whatever symbol you feel comfortable with. It's nice that we're not all running around with Kenwoods when we're up there, since we know everyone's a Kenwood, but everyone's running around with a tent too. Nothing particularly special about the tent symbol for the Golden Packet event. It's just standard.
Lynn,
TX
could you back up a couple if you would? There you go. The *1 and enter text. What's the *1?
If you look in your D710 manual or at your faceplate, it's the first entry that you get to put text into. And
Okay, it's just the index. Okay.
Yeah, and
Okay.
then there's a use button on that one as well, I believe, to put the star on the one that you want to use.
That's what I was worried about. Okay.
Yeah, I think there's a use button on that, but like I said, I took this text directly out of Bob's notes and he did not mention use on this one.
Understood. Thanks.
I'm pretty sure there is. Yeah, I'm pretty
Okay.
sure you need to.
And I believe, at least on the D72, it's text number 5 that lets you put your automatic QSY information in. And I believe it might be the same way on the 710s, that it's only the 5th entry that will put your QSY information in for you. Good question. Symbol transmit timing. We want these things to beacon at a fixed interval. That's why we're not messing around with smart beaconing and GPSs and movement and all that stuff. Your beacon algorithm needs to be auto. Your initial interval is 10 minutes, except in the original notes, it says Springer and Katahdin use 5 minutes because we want them to be a little bit more often to give them a better chance of getting end to end. You definitely need decay off and proportional off. What decay does is it's going to double that interval every time it transmits unless your location changes. So it's kind of like a poor man's smart beaconing that picks up the parked vehicle and slows down a lot, but it's going to double your interval until you move again. So you definitely need decay off. Proportional pathing plays around with your path every other beacon. It'll beacon once with no path. It'll beacon once with your first path term. It'll beacon again with no path. Then it'll beacon with both path terms. Then it'll beacon with no path and so forth. So you don't want proportional pathing messing around with your beacons on the Golden Packet Trail. But then Bob updated in 2020 timing suggestions for better performance. And I don't know how widely this got propagated to people to reconfigure their radios. But here you can see which station is supposed to be beaconing how frequently. And the idea is that the ends of the chain beacon most often. We slow it down as we come to the middle, and the middle beacons least frequently because they're going in both directions and are more likely to be seen then. Yes, John?
This list of stations needs to get updated. You still got Sugarloaf on there.
Yeah, I'm gonna clean it up. Don't worry about it. Yeah.
Okay, good. This was the other place where I had the list of stations. But
I've
like I
got
said,
it on my list.
I don't know if we actually did all of these timing changes last year or the year before. So
Unfortunately, I think we kind of get into like a frantic state because people having issues that we're trying to work through, and we never really have time to go through it methodically.
Right, but this can actually be done right from the get-go. You don't have to change once you're on site.
Yeah.
Because originally everyone was doing 10 minutes. So this is going to make some people go faster. Really good idea, and it should improve visibility of the ends of the chain getting to the other end. And then we have a whole bunch of miscellaneous settings that are just as critical as the rest of the settings, some of them, but really don't get stressed a whole lot. 606 we mentioned before, you want the speed, the altitude, the ambiguity all turned off. You want the Mickey comment to be special. 609 is really an insidious little parameter. 609 is the position limit. You're supposed to configure it for off. What that is if you receive a packet that's further away than your position limit, the radio won't show it to you.
Yeah, just discards it, right? Yep.
Yeah. Which means the whole point of this is we want to see stations that are really, really, really far away from us. So it's really important you make sure 609 is turned off in your radios.
Okay.
613, you definitely need that set to APRS and not the other funky thing that I forget what it is. But it's a completely different protocol that it uses over the air and would make you completely disappear from the Golden Packet event. 614 is just for your own sanity. You don't really need voice alert putting tones on. We either have our squelch set to hear it or we don't. 622 is another important one. It's only listed on the 710G, but it really is for the 710 as well. You don't want auto reply. If somebody sends your station a message, you don't need your station automatically replying to them and sending the, I'll get to you when I can, back up the chain. 625 for interrupt always has to do with how the packets are shown on your radio. That's going to come up when I get to, if I get to, one of the diagnostic aids you can do on your radio to figure out what's working and what's not. Now we get to the real critical one. Offset the path. Path is menu 610. Definitely has the use button to pick which one you want to use. You need to set it to others. And then you configure your others path to the hop 77, hop 77. There are no spaces in there. There is a comma separating the two terms. That is all critical. One year we actually had someone transmitting a hop space 7-7 and it didn't work. Their packets were not being digipeated until we noticed that being received on the ends that weren't digipeating them. This is one place where the magic word hop appears. This is where my station is saying, I want the Digipeaters that honor hop to act on my packet. So the hop 77, hop 77, HOP can be anything you want. Making it shorter does not save anything because it's going to take that 7 bytes worth of path component in the AX25 header, no matter what the word says. But the real key is the Digipeat settings. The intent behind this is we only want our Digipeater to respond to the custom ATGP hop alias. We want that hop alias to use UI flood to keep the packet shorter. We want a temp alias to use UI trace so that we can do localized Digipeater testing. I suspect this has never been done by any station along the trail, but you can literally, you should be able to go back to your path, configure it to temp 2-2. And when you transmit your next packet, it should be digipeated by the adjacent station and the next one beyond them, and then stop. And it will do that with a UI trace so that you can see what those Digipeaters were on their way out. So we want the temp alias to use UI trace. We want the hop alias to use UI flood. We do that because in menu 616, we set the my call to on. Yeah, this would allow someone to say, I want Mount Wash-14 to digipeat my packet. We don't use it that way, but we have it enabled if we ever needed to. 617, the UI check time of 10 seconds. The default for this value is 20 seconds. This is that Digipeat dupe delay. If I have digipeated this packet within the last 10 seconds, I'm not going to digipeat this packet again. Default of 20 seconds makes it really, really hard for us to do the tricks we do of Springer. Can you trigger 3 beacons in a row? I guarantee only the first one's going to be digipeated by, who's right after Springer? Klingman's Dome. I guarantee only the first one's going to be digipeated by Klingman because the other ones came in within the 10-second window. And if it was defaulted to 20, it would be really hard to force packets through Digipeaters. So important one to set to 10 seconds. UI Digi off because we're not messing around with that wide 1-1, just replace it with me. We want the UI flood on, and this alias hop in menu 619 is the other place that that magic word appears. So if we wanted to change hops to XYZ, it would be menu 619 and menu 612. The only two places you need to change it. But everyone on the trail has to agree on what it is before we get there, or it's not going to play. Substitution ID is the other one that's important. If you do the substitution no ID, you can't tell what Digipeater even acted on it most recently. And finally, menu 620 is where we put the alias temp. That gets us the traceability of the temp alias. In actual fact, Bob's recommendations for the national APRS is all the mobiles are supposed to be running around with UI trace turned on with an alias of temp. And that way anybody can use one of those temp Digipeaters just because there happens to be a D710 within simplex range. Don't know if all of our D710s are actually configured that way or not. So any questions on the settings that we do in our radios and why we might do those settings in our radios?
Hey, Lynn, quick question. Back in
Yep.
2019, you called me on the phone when I was up at Hawksbill and knew that I had a hop 77, I think, period hop 77. What confusion did that create on the trail?
The confusion that creates on the trail is it's not actually going to transmit both path components. I'm not sure what the D710 actually was putting in the path, because you can't put the dot actually doesn't, the comma doesn't actually go in the path. So what I know is it would not have been properly constructing the path to get a full 14 hops. But
Okay.
what it was really doing, I don't know. Actually, I don't think it was the comma you had a dot. I think you had a hop 7.7.
Maybe that's what it was. That might have
And
been
a
what it, I just know there was a dot in there somewhere.
Yeah,
That might have been it.
I think it was a hop 7.7. And I know what that would do is it would literally put into the path alias HOP 7.7-0. And there's no Digipeater on the trail that's going to act on that. So it made your station not be Digipeatable because it was not requesting the services of a Digipeater that was looking for a hop 7.7.
Right. And we fixed that. And we didn't notice that until you called me and told me I had to turn my squelch on.
Right. And those two things are coming shortly here. Because unless there's more questions, I'm going to dive into the final phase of the presentation that obviously now should have been 2. Hearing none, pre-event checkout. Simple things that y'all can do before you actually take your rig to the trail. Put your radio on 144.390 and beacon. You should see your AT Golden Packet station show up on APRS.FI if you're in simplex range of an iGate, because you're going to be beaconing with a hop 7.7 and there's no Digipeaters on the national frequency that should be acting on that. But it's a very quick test. If you can get your Golden Packet station within simplex of an iGate, you can see your packet on APRS.FI. You can listen to 144.390 on another radio. Force a beacon from your Golden Packet station and learn what your packet should sound like. Packets, it's real easy to hear good and bad packets if you listen to the packets. And this takes just a normal audio HT can monitor your packet and listen for it. You can even do it on a different frequency if you want, so that you know it was your packet that you heard. If you're blessed of having a second APRS radio or a direwolf instance that you can talk to separate and apart from your Golden Packet station, set that second APRS station to use a path of hop 7.7 and do a beacon. Watch your Golden Packet station and listen for it to do a Digipeat. If it's Digipeating, you should see it transmit immediately after it received the packet, provided your squelch is closed. So very easy to see, but what you might need to do, oh, that's not it. It's not on this slide. You might need to change your interrupt and display features on your Golden Packet station, because in some display modes, the transmit bar is hidden by the received APRS packet. So you need to set it up so that you can actually see the transmit bar, or if you're able to listen to a radio, you can hear your beacon and then the Digipeat beacon. You can then configure your temp 2-2 on a second APRS radio and see that that actually digipeats through your Golden Packet station. You can play with your status text and learn how to navigate and actually change that text easily. And you can either view that on your second APRS radio, or if you're in simplex range of an iGate, you can see it at APRS.FI. You want to get really fancy? You can compose and send a BLN XXXXX message. It's literally a message addressed to BLN 0, and the 5 characters are optional. You don't have to put them in unless you want to. And you transmit that message. My D72 transmitted that message 5 times. Even though it was not looking for an ACK, it still transmitted it 5 times. I guess it's supposed to do that with bulletins. I don't know enough about it, but if you go to APRS.FI, you can actually view the bulletins that have been received on the APRS-IS in the last 24 hours. And that packet that I had from AO Mountain that was BLN 0 AOMTN, I actually saw that at APRS.FI because I tried that packet from my D74, I think is the one I had the antenna on. So those are things you can do pre-event to make sure your Golden Packet station has a good chance of working when it gets on site. And when things go wrong, or don't go the way we want them to. Popular things we see: station isn't transmitting on the APRS. Nothing's being received or decoded. The station's not digipeating. I'm only seeing one adjacent station and not the other one. I'm only seeing the adjacent stations and nothing beyond them. I'm not receiving messages. How do I get a hold of the Shack Potato if I don't have cell service? All good questions. We're gonna go through them one at a time. And I will be, if anyone wants to drop out, you're welcome to, but you're welcome to stay too, because this part is good stuff too. And I apologize for going long. It's a bad habit of mine when I do presentations. So if your station's not transmitting APRS, first thing to do, make sure squelch is closed on the APRS channel. It's not going to transmit if the squelch is open. So you don't want to listen to the static. It's not a good idea because you won't transmit in that mode. Check your DCD sense, because if it's set to both bands, it's not going to transmit if your UHF band is actively receiving. So if you're sitting there having a rag chew with your guys up next door, you're not going to be transmitting if you're in both band. Make sure that your beacon is turned on the display. There's one of the menu buttons on the 710 lets you toggle the beacon on and off. Make sure your beacon's toggled on, or obviously it's not going to transmit the beacons. And then make sure that your GPS is off and that you have a position set. The D710 will not beacon a position if it doesn't know what location it's in. So you need to make sure that's set up. So that's the things I could come up with for what to check if your station's not transmitting. Anyone have any to add to that list that you've run into? Nope. Okay.
Make sure your antenna is connected.
Well, you'll transmit even if the antenna is not connected, right? It's just not going to go very far.
Good point. Yep.
Burn out your
And even-
final.
So I've actually run that test. It's a very bad test. You then need a new final.
Yeah, exactly.
And worse, I bet you can even still hear the packet on a local HT without an antenna. It's going to radiate some. If nothing's being received or decoded, open the squelch and listen for packets. Very simple thing to do first. I'm not receiving anything. Let me listen to the channel and see if I'm hearing anything. If I'm not hearing anything, obviously nothing's going to decode. If I'm hearing something and it sounds kind of muffled and staticky, obviously it's not going to decode. That's why I mentioned you need to listen to your own packets and hear what they sound like, so you know what a good strong packet sounds like. Double check that you're on the that the APRS band is on the frequency you want. If you want, switch that band over to 390. The positions we're taking up along this trail, on 390, you should hear packets. And you should hear packets you should be able to decode because of the altitudes we're at. Might not be so true for Katahdin, but I bet everywhere else, if you go to 390, you're going to get packets. And that'll verify that receiving and decoding is working, and it must be something on the trail that's causing us the problems that makes you not to do. Like I mentioned back in menu 609, make sure that's turned off because you're not going to see what you're decoding if the station's too far away because of the position limit. If you're not getting packets from a station, get on the voice channel to them. If you have a voice channel working, make sure they're transmitting. They may not be aware that their squelch is open and they're not transmitting. You're sitting here trying to figure out why you're not receiving when in fact they're not transmitting. And a real, unfortunately still happens, reason that you may not be receiving and decoding. D710s have 4 filters in them. Because of the circuit design, they do not have blocking capacitors on them. That's not really the problem. The problem was there was a bad batch of crystal filters built into D710s, and TS2000s, I believe, are also affected by this. What happens over time, and time is variable depending on how much the radio has been used, the crystals will grow little tendrils and your channel will go deaf. There are 4 of these filters. There's a wide and a narrow FM on each of the A and B bands. So depending on what you've been using, you may be able to diagnose this problem by changing menu 601, or switch the bands in menu 601 to the other band, change your frequency and things, see if things get better because now you're using a different FM filter. You can also use menu 102 and change from FM to narrow FM and see if the packet gets louder. This is really what you'll hear is the packet sounds staticky and muffled because the filter is making your D710 go deaf. Recovery from that is you got to get the filters changed out, but in the field recovery from that, go to the other band. That filter might be in better shape. I don't think we can get away with going to narrow FM.
This is 710 only, not the A's or the G's, correct?
There is a certain range of serial numbers that I could not find when searching for it when I put this slide together. I was going to put the URL for what the serial number range is. I think it's only the A's, not the G's, but I can't guarantee that.
Oh, I thought it was just the 710s, not the A's.
Don't know what it actually affects, but I know it's some set of D710s and TS2000s that had this problem.
Jeff, maybe make a note that we could get that serial number range or something so everybody can check their radios before next summer.
So is it fairly well known that there is a range?
I have seen sites in the past. I could not find it when I went actively searching for it, where you could put your serial number in and it would say whether or not you're affected, and it published the serial number ranges. Kenwood has never acknowledged that this is truly a problem because it's not a design problem. It was a bad batch of filters.
Sure. Yeah.
That aggravated the problem. The YouTube video that the link is here is really interesting to watch because he literally shows you the filters. The crystalline growth can actually come outside the housing of the filter, and you get a white crystalline deposit on the outside of the filter in a really bad case. So that can be a reason.
Which slide number is this?
35.
Thank you.
Sure. Your station's not digipeating. You should see a transmit immediately after receiving and decoding a packet. The way our paths are set up, every single packet you receive and decode should digipete. If you're not, you might need to change the display area so that you can see that transmit bar that's somewhere buried in menu 625. I don't own a D710, so I could not verify that. But you can play with that on the national frequency and see what display features make the transmit bar disappear or not. But first, before you worry about your station not digipeating, make sure that you're transmitting and receiving packets. Because if you're not receiving packets, you're not going to digipeat a packet. If you're not transmitting, you're not going to transmit the digipeat. So those first two have to be working before you get to this point. A question to D710 owners. Is there a way, looking at a station on the faceplate, that you can see the path of a received packet? You should be able to go to the list and just pick a station, and there's a couple of pages I think you can go through of information. And
What
I
was the
think
question? I guess it was sent directly to you.
on a D710 faceplate, can you see on the display what path a packet had that was received?
I
I think John's looking at his 710 right now.
believe that, yeah, I believe you can look at the raw packets.
Well, I know you can go look at the list of received packets, the ones that have been properly decoded. Click on that one and then scroll right and scroll through several screens of data about that packet.
And is one of those screens, does it show the path?
Yes, it does.
Lynn, if you, I have this in front of me. So when you hit the list, you see the list of received stations. When you select one on the next screen, down below where you have those arrows to go through, there's also a button called path. You hit the path, and I did this on one, and it shows me first and last on the path.
I was afraid of that, because we may need to see the whole path, not the first and last.
I'm pretty sure that I don't have the 72 in front of me. I normally work with a 72. 72 memory was about screen 3. It actually had the full path, but I'll go check.
Okay, we really need to know it for the 710.
Yeah,
That's
got
what
it.
most
Okay.
Mine is packed away. Otherwise, I would look right now. But yeah,
So this slide number 36, if someone has a D710 that we can see how to see the received path, this is where we would have seen the station not digipeating the hops 7.7, because we would have seen that in the path and said, obviously, I'm not going to digipeat that. We would have called the person, the other station, and said, hey, fix up your path. You got a dot in there instead of a dash. So this
It looks
is
like I
why-
can only see the first and last. I do have a 710 on my desk here.
Yeah,
I mean, I know
That-
it's visible if you hook a serial cable up to the radio and you have it output, but that's obviously not on the display.
right. So being able to see, now that we know how digipeating works, if we see what the path was that we received, we find the first unused piece of that path. That's what we want to look at and make sure it matches what we're expecting to digipeat. Hop 7 dash something. Because if it doesn't say that, we're not going to digipeat, and it's not our fault. So that's the diagnosis of a station that's not digipeating. If I'm only seeing one adjacent station, I'm seeing the north station, but I'm not seeing my south station. The brain dead obvious thing is check with your south station, see if they're on site and transmitting. Yes, I've had that call. And coordinate by voice, listen for packets by opening the squelch, but remember to close it back up or you're not going to transmit. This can happen. We saw in one of the hops, I don't remember which one it was, by antenna placement. They had one place they could be to get to the north, and they had to move a little bit to get to the south. And there was one magic spot where they could get to north and south, and there wasn't a big difference between the two. So it helps to know your site and know what your options are and know relatively where it is you're trying to get to. But that's usually, if you're only seeing one side and not the other, it's because the other one's not transmitting. They either didn't show up or they're having issues. A more interesting one is you're only seeing your adjacent stations or one of your adjacent stations and nothing beyond them. This is usually an indication of either the one beyond them is not on site yet, but once we know everybody's on site and transmitting, the one that you're not hearing beyond is probably not digipeating. And this is where, as the shack potato, it became very obvious when we had a station that wasn't digipeating, because the people south were only hearing up to him, the people north were only hearing down to him. He was the whole. He wasn't digipeating. That might have been the hop 7.7 that was in there, but I don't think that was it. I don't remember what the actual problem was, but it was if the station adjacent to your adjacent station's not digipeating, your chain is going to end with them. And they're going to sit there and say, but I can see both ends of the chain. There's no problem with me. Well, there is, because nobody outside of you can see the other side of you. You're not digipeating. You're not receiving messages or bulletins. Real easy solution. Clear your message list. I can't tell you how many times I've seen new APRS travelers going by and I want to send them a quick APRS message and I get back a reg. Rejected. D700, D710s have a fixed length 100 message list. And if they have that many messages in their list, they will reject any incoming message by sending back a REG instead of an ACK. So if you're not getting messages, clear your message list. If you have a mobile D710, clear your message list every month or so, because people like me might want to say hi someday. Bulletins are just specially addressed messages. They transmit not expecting an acknowledgement, but they do retransmit 5 times in the test that I did here. We use the bulletins rather than directed messages on the ATGP because they don't need the ACK. So you just address it to BLN, literally, Bravo Lima November, and a digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A through Z even. Beyond that is optional. You put your text in just like a normal message and hit send. And that bulletin will show up on everyone's radios up and down the trail, depending on what path you're running at the time. Directed messages are really frowned on in the ATGP because they need the ACK to come back before they'll quit retransmitting. And if you're going more than just your neighbor, you're lighting up the whole trail with your message just to get to your neighbor. And finally, shack potato contact. I think I've probably spoke with most of you when you were on the trail. If you have cell coverage, call me. Keep me in the loop. Sometimes that's the only way I know what's going on so I can relay it to other people. If you don't have cell coverage, but you have voice to an adjacent station with cell coverage, do a relay through them. I talked to several stations. Just what's really nice is when I can hear their UHF radio on my phone and I hear them relay what I said, and then I hear the answer direct, so they don't have to repeat what they heard back. If you have a contact outside the event, arrange a relay with them. If you've got a local repeater and you can raise someone on the repeater, then they have a phone, have them call the shack if you need to get in contact with me. There was one station, John, I relayed to you through him quite often on one of the years, that he had HF contact to you, I think it was.
Yeah, he was down like in Farmington, Maine. And we could get a link to him and we had a phone in the shack. He was sitting in the shack. So we got him to be our relay point to you.
And it was gorgeous that we had that contact, that we could reach the north part of the trail, which is really, really hard to reach, honestly. If you have 144.39 APRS access and you happen to have a second APRS radio, send an APRS message to the shack. KJ4ERJ, I'll see it. And even if you're only in receive only iGate coverage, the message will still get to the IS. I just won't be able to reply back to you without a transmit capable iGate. So if you can get 390 coverage, one way is better than nothing. You can use APRS message.
We set a time to test this well before the date. I want to,
Yeah, we can. Yeah, we can. Let's
Sure.
just
Yeah,
we'll start
you're gonna be
socializing it.
available.
We can start socializing it on the group here in the next couple of weeks.
That'd be great. And use APRS messaging to your adjacent station on the trail. You can go to your path, change it to a temp NN, so you're not lighting up the whole trail with your message. Just change it to a temp 1-1, and you'll reach one station beyond your neighbor. You set your path to empty, and you'll reach your neighbor. And you can do APRS messaging to your neighbor even if you don't have voice to your neighbor. Some of you may have wondered, how in the world do I do this as a shack potato? Because my wife keeps telling me I need to train someone to take my place one of these years. I have a POTS line. That's plain old telephone system. Literally, it's copper into my house. It has call waiting deluxe, which is a feature a lot of phones don't support, and three-way calling. If those two lines are busy, it rolls to my cell, which has a different phone system in my house that I answer it on a normal phone as well. And then that will roll to voicemail if all three of those lines are busy. And I know some of you have gotten caught in my impromptu conferences because I'm talking to one person and somebody else rings in on the call waiting deluxe. There's a feature of the call waiting deluxe that lets me answer the phone and immediately conference, which is why that happens so quickly. Normally with call waiting, you can ping pong between the two calls. Call waiting deluxe lets you make a three-way call out of the call wait. So that's how I pull off that magic. Not hard, but literally my wife has walked into my office and seen me sitting here with a headphone on both ears, talking out both sides of my face. So that is all I had prepared, only twice as much as I needed. And are there any other questions? Because my theory is there's no such thing as a stupid question unless you asked it before and are expecting a different answer.
John, how about and serve, that mechanism? I mean,
Yeah, we
Lynn,
do
I'm
need to
sorry.
talk about and server.
That is another way to get to the shack potato. Yes, the ANSRVR. It's just like sending an APRS message, except everybody that's subscribed to AN server gets it. I was going to list that here, and I thought, you know, that's another whole 2 or 3 slides to say how all that plays together. So I skipped it. But yes,
Got it,
AN
thanks.
server works.
Lynn, this is John. I know it's getting late. And I want to really thank you for doing this. I learned a
Yes.
lot here tonight. And I think it'd be great if we could do another session with you before the actual trail.
That can be arranged. Depends what all Jeff has in the queue.
Or even if it's not the formal monthly call. Because, yeah, I mean, I just like the stuff I'd like to talk to you about, but I don't want to keep you here this evening.
Right. What we can do, Jeff, we could
Mhm.
set up a, just send an email to the list and say anything that you want to discuss with particular individuals, and we'll start accumulating a list of discussion topics and then
Yep.
just schedule a call to do those topics.
Yep.
Because I can talk extemporaneously.
So something I've been thinking about, especially just based on a bunch of the content in this slide, in this presentation, is, you know, maybe putting together like a laminated, you know, 2-sided document for each site, sending it out to them that has the detailed operating procedures, the schedule, you know, everything that they really need to know for the day of the event, so that, you know, they've got everything all in one place, kind
That would
of
be nice.
step-by-step procedure, how to log into AN server, you know, contact info,
Yeah, that would be sweet.
bulletin format, right?
Yeah, how to format a bulletin message.
Yep. So I mean, that's just something that, you know, if you guys have ideas around how to structure something like that, even if it's not, you know, everything soup to nuts, just little bits and pieces of content, just share it and I'll stitch it together. Lynn, thank you so much. This is absolutely incredible. By
Jeff,
the
will you
way,
be able to share the slides?
yeah, we're gonna share the slides and the presentation, or and the video rather.
Yeah,
Okay,
the recording and the slides will all be available.
very good. Thank you. Thank you, Lynn.
And John?
Lynn, and admittedly, I knew this was going to run a lot longer than an hour when I saw how many slides you had, but I said, we've got your time. Let's just, you know, let's get it down.
My pleasure. I felt like some of the background may not have needed to be covered, but it made it a much more complete wrapper.
No doubt about it. Yeah, no doubt about it. It's all one-stop shop.
And John, one thing that would be really sweet to add to this for the new stuff we're working on with Direwolf and the pies is how to accomplish all those D710 settings in Direwolf.
Mm.
Yeah, I jotted that down, that you want
Okay.
tracing for temp, but you want no ID for hop.
So
So
we want ID, but not trace. We want flood with ID.
yeah, I jotted down the requirements.
Okay.
And
I have a strong feeling it's doable, but I have never configured a Direwolf Digipeater, so I didn't know how to even start.
no, it's currently not possible to not do the tracing.
Ah, okay.
So I'll have to add an option for this.
Very good.
Wonderful. I'm stopped the recording now.
And all we need to do for that